Alright guys, number 9. We're finally into some series parallel combination circuits now. Now, what we want to do is we want to just follow the current through this circuit. So we go through R1. Looks like we branch off. So there's a parallel branch right there. We go through 2 and 3. We combine back to here. We go through R4. There's another parallel node where current branches off in 2 different directions on 5 and 6. Then it comes back to the same point and then goes back to the source. So what we need to do is we need to find the parallel combination of, let's see, 2 and 3 and 5 and 6. Those are our 2 parallel combinations. Okay, beauty. And then we can add it in here because we know that RT is equal to R1 plus whatever we get for 2 and 3, right? So let's do R2 and 3 first. Let's do the product over sum, so 200 times 300 over 200 plus 300. Now be careful with your calculator. Some calculators require you to have that bracket there. Otherwise, your calculator is going to go 200 times 300 and then divide by 200 and then add another 300. We want it to divide by 500, so you may want to make use of the brackets there. We know that the combination of these guys has to be less than 200, and we punch this into your calculator, it gives you a value of 120 ohms. So this guy is the same as 120 ohm resistor. So let's see, this guy is 100 ohms for R1. This guy is going to be 120 ohms. Then we're going to add in R4 at 120 ohms. And then we just need to find the parallel combination of 5 and 6. So R5 and 6 is 200 times, now be careful, I tried to screw you up with the kiloohms there, so that's 1800 ohms over 2000. So again, that combination of 5 and 6 is going to be less than 200 ohms. And because this value is quite high, it will be closer to 200 ohms. And it gets to be 180 ohms. Excellent. Now we can find our total resistance. Total resistance is 100 plus 120 plus 120 plus 180. Total resistance ends up being 520 ohms. Okay, so we found RT. Next thing we need to find is IT. So in this case we have 48 volts. We have 520 ohms. And if you take 480 divided by 520, it gives you a current of 0.092 amps. Or we could say 1, 2, 3 decimal places. It's essentially 92 milliamps. Excellent. Okay, so we've taken a somewhat hard circuit there with the series parallel combination. We've broken it down using the rules that we used before on previous videos with the product over sum. And we know that the total resistance for a series circuit is the sum of all of the resistance values. Looks good, guys. Okay, press stop and then move on to number 10.